All right, hello everyone, this is Mr. Underkoffler again, and this is a real quick video, hopefully, on reviewing writing algebraic expressions, which is something that you probably already had learned in 6th grade math, but even if you forgot some of it, this video will pretty much review the basics of how this works. First of all, algebraic, that word means there's going to be at least one variable. So when you're writing an algebraic expression, something has to mean a variable. Well, what could that be? It could be verbal phrases like a number, where they never tell you what that number is, or the score of the team, and they never tell you what the score is, or the amount of Amy's salary, the Beau's height, or any phrase that they would represent a number, but that we don't actually know what that number is. And so we're going to use a variable to represent that type of thing. Now, vocabulary. This page, this chart, you're going to be looking at a lot. Some of these phrases you might remember from years past, like sum of is addition, difference of is subtraction, product of is multiplication, quotient of is division. Lots of different phrases here. That can mean addition, subtraction, multiplication. Only one really phrase that we use for division, and then there's a couple phrases here that mean very specific exponents. Square of is second power, cube of is third power. Some of these phrases for multiplication are very specific, like anytime you have a number followed by the word of, then the word of actually means times. Twice means 2 times specifically. Half of is kind of like a number of, so that would be half times. One thing I want you to be aware of, the phrase less than and the phrase fewer than, and I want to apologize, the phrase fewer than should have also had an asterisk. I think your copy probably already has the asterisk there, but the asterisk is this right here. The order of the way that you write the math, the order will switch whenever you are translating subtraction phrases like less than, fewer than, shorter than, or any two-word subtraction phrase that has the word than. The order will need to switch from how it was in words. So you're going to see this on example 2, which will say 18 less than. The 18 will not actually stay to the left. It'll switch. It'll end up on the right. You'll be subtracting by 18, not from 18. And you'll see what I mean when we get to that. In fact, let's just go ahead and start with that, even though I'm kind of going out of order here. Normally, you keep the translation into math the same order as it was in words. So actually, I won't go out of order. We'll start with number 1. Kadim's salary. We don't know what Kadim's salary is, so we'll pick a variable for that, S. Increased by, you can look up in the chart, means plus. 800 means 800. So you see how it's pretty much normally the order that it was in the verbal phrase, but if it's a subtraction phrase that includes the word than, then the order will switch. Let me show you what I mean. Problem number 2. 18 less than. Well, less than means minus, but the 18 will not stay on the left. It will actually end up over on the right. So the order switches, just like I was trying to show you there with the asterisk underneath the chart. So what's next? Half of their profit. Half of means half times. Now, sometimes you have to use a times dot. Don't ever use X for multiplication. That's a big no-no. But if the half is being multiplied to a variable, then you don't even need a times dot. So what does it say? Half of their profit. Well, we don't know their profit, so that's going to be a variable. So again, notice how in number 2 the order is switched. That's only going to happen when you have a subtraction phrase that includes the word than. It could be less than, fewer than, shorter than, smaller than, younger than. I could go on and on. But if it's a subtraction phrase that includes the word than, then the order switches. All right, problem number 3. Twice a number. If you look up in the chart, twice means 2 times. Now, don't use X for multiplication. Something I'm going to keep reiterating here. Instead, use a times dot, unless it's going to be multiplied to a variable. Well, it says twice a number. We do not know what this number is that they're talking about, so we will pick a variable. Normally, we pick variables that kind of coincide with the first letter of the word. So like Kadim's salary, I chose S for salary. Twice a number, I chose N for the number. But you can choose generic variables if you want, like X or Y. It's totally up to you. All right, back to number 3. Increased by 27 is how this verbal phrase finishes. So that would mean plus 27. Decreased by would be minus if we had that. You can see that up in the chart. All right, problem number 4. Twice the sum of a number and 27. Now, you might initially think that number 4 is going to be exactly the same as number 3. But it's not. Let me show you the difference here in the details. Problem number 3 said that we are going to take twice, which means 2 times, the number. Number 4 says we're going to take twice the sum. Now, what's the difference? A sum is an addition problem, or it could be the answer to an addition problem. We're not going to know the full answer to the addition problem because what are we summing? We are taking the sum of a number and 27. That's what has to be summed. That's what has to be added up. So we're not going to know what that answer is because we don't know what the number is that they're referring to. That's an unknown. So back to the details. It did not say, problem number 4 did not say twice the number. Problem number 3 did, not number 4. Problem number 4 says it's twice the sum, which means the entire sum, the entire addition problem has to be twiced. How do I show that the entire addition problem of n plus 27 is going to be times by 2? Well, you probably don't know, so I'm just going to go ahead and tell you. And this is something you might want to star on your page, because this could also occur with the phrase difference of. See, sum of and difference of, they're very similar, except one means addition, the other means subtraction. Even product of and quotient of are kind of like them, except they're multiplication and division. But if you ever have a number times a sum, or times a difference, which would be a subtraction problem, then the only way to show that the entire sum or the entire difference is being multiplied by the multiplier is to put the sum or difference in parentheses, like you see here on number 4. So that's the big difference between number 3 and number 4. Something that you should take note of for the future. All right, problem number 5. $21 more than 85% of the original price. All right, this starts to get a little bit more complex. Let's make sure we're breaking it down piece by piece. We know 21 is 21. More than means plus. Now, more than is kind of like less than, except it means addition. And I know I told you that with less than, you have to switch the order. Should I switch the order with more than? Well, it means addition. Does the order of addition really matter? It really doesn't. So I don't really care if you switch the order here with more than, even though you had to with less than. More than's addition. Doesn't really matter. So if you want to put the 21 on the left, fine. You want to put it on the right, fine. It will not matter because the order of addition doesn't matter. All right, what's the next part of this? 85%. Now, do you remember from 6th grade math what percent really means? It really means something out of 100. And there's 2 ways you can write that. You can write that in the decimal form of 85 hundredths, or you could write that in the fraction form of 85 hundredths. So really totally up to you which way you want to do this. I prefer the decimal form because it's a little bit quicker to write. And then what does the rest of the problem say? 85% of. Now, remember what I showed you in the chart. When you have a number followed by the word of, that unique situation will be when the word of means times. If something else is before the word of, like sum or difference, then it won't mean times. But if it's a number, and then to the right of that number, immediately to the right of it, is the word of, then the word of means times. And that's what we have here on problem number 5. 85% was the number, 85 hundredths. Next up is of. So this means 85 hundredths times whatever is next in the problem, and that would be the phrase, the original price. We don't know what that price is, so it's going to be 85 hundredths times a variable, the variable representing the original price. I would pick P. I would not pick O. O looks too much like a 0, so P is probably a better choice. And like I said earlier, it doesn't really matter which order you have the addition in. Really won't matter as long as 85 hundredths is times to the original price. Then the plus 21 could be to the left or to the right, won't matter. Problem number 6, 33 less than the square of the weight. All right, here we have less than. That means minus, but the 33 must be on the right of it. That's just the way less than, fewer than, shorter than, any subtraction phrase that includes the word than, the order must switch. So the square of the weight will actually go to the left of the minus. By the way, square of was in the chart. It's one of those phrases that means a specific exponent. Here it's the second power. Cube of would be the third power. So the square of the weight means the weight is being taken to the second power. What is the weight? We don't know. We'll pick a variable. All right, so there's 6 problems of just generic verbal phrases and how you would translate them into what they mean mathematically. Normally you keep it in the same order unless it's a subtraction phrase that includes the word than. All right, now one more on this page, and then there's a whole bunch of practice problems in the back that you will do on your own, and this video does not do those problems. You can just check your solutions later. If you think about it, in real life, when we talk about totals, we are often adding parts together. Now, I said not always. Here's why. If you are buying multiple quantities of something at the same price, like if I go to a store and I buy 3 t-shirts and they each cost $12, then I don't have to add, do I? I could take 3 times 12. So whenever you see words like each or per, they often are going to be implying multiplication, like $20 for each pair of jeans. And I buy 4 pairs of jeans, so I would take 20 times 4. Or I work $8 per hour, and I worked for 5 hours, so I would take 8 times 5. So words like each or per often mean that the price or the cost is multiplied to whatever quantity of something that we're talking about, whether it's jeans that we're buying or hours that we're working. That's what we're doing. But aside from that type of situation, the word total would often mean adding parts together. Okay, so with that in mind, let's take a look at number 7. The table shows the prices of food items from a fast food restaurant. Write an algebraic expression for the total cost of M burgers, N packages of fries, and 2 sodas. So this is a little unique. Normally we know how many burgers we're buying. Normally we know how many packages of fries we're buying. But on this problem, they don't really tell us. They just call them generic variables. I'm not sure why they chose M for burgers and N for fries, but whatever. That's what they chose. So what we're going to do is this. What would we do in real life? If I would buy 4 burgers, I would take the price of the burgers times 4. So on this problem, I would take the price of the burgers times, well, not 4. They didn't tell me it's 4 burgers. They told me it was M burgers. So you would take the price times the unknown amount that you're buying. But to get the total of all these things, I have to add it to the price of the fries. And the price of the fries is $1.50. How many fries am I buying? N packages of fries. So it's $1.50 times N. Think about it. In real life, if it was $1.50 for a package of fries and you bought, say, 6 of them, some for you and your friends, you would take $1.50 times 6 to get the total cost of those fries. So here's $1.50 times N. Same idea, except it's a variable. And finally, 2 sodas. Okay, this time it's not a variable for the number of sodas. Instead, it's exactly 2. So we're going to take the price of the sodas, 95 cents, times 2. Now, if you want to write that as $1.90, because that's what 95 cents times 2 is, fine. All right, take what you've learned from the first page and the video that I've used to go over this first page. Take that knowledge to help you complete the practice problems on the next page. Thanks for watching the video. We'll see you next time.